On the night of August 17, 1943, beneath a sky darkened by smoke and searchlights, a wave of Allied bombers crossed deep into occupied Europe towards a target hidden among the forests of eastern Germany. Below them lay a place that few outside the German military establishment had ever heard of. It was not a major city. It was not a traditional industrial center. Yet inside its fences, behind layers of secrecy and deception, engineers were attempting to create weapons that could change the course of the war. This was Peenemünde, a remote research facility on the Baltic coast, where scientists, technicians, and forced laborers had spent years developing a machine unlike anything the world had ever seen. The weapon was known as the V-2 rocket. It would rise beyond the reach of conventional aircraft, travel faster than the speed of sound, and strike targets hundreds of kilometers away without warning. For Allied intelligence officers, it represented a terrifying possibility, a future battlefield where enemy weapons could cross continents in minutes. The air above Peenemünde trembled as thousands of engines approached. Searchlights swept across the clouds. Anti-aircraft guns opened fire. The raid, known as Operation Hydra, was the first major Allied attempt to destroy Germany's long-range rocket program. British bombers released thousands of tons of explosives, tearing through workshops, laboratories, and living quarters. The attack caused significant damage, killed hundreds of people, and forced Germany to move much of its rocket production underground. But it came too late to stop the program entirely. Deep within the German war machine, a vast and secretive effort had already transformed an impossible idea into reality. The men behind it believed they were building the future of warfare. Their work combined advanced physics, engineering ambition, military desperation, and the resources of a regime determined to find a miracle weapon as defeat approached. The story of Hitler's secret weapons program was not a single invention created in isolation. It was a network of projects spread across Germany and occupied Europe, involving rockets, jet aircraft, guided missiles, experimental tanks, and revolutionary aircraft designs. Some would become important technological milestones. Others would remain costly failures, consuming enormous resources while delivering little military value. At the center of this program stood a question that haunted Nazi Germany throughout the Second World War. Could technology overcome the overwhelming industrial power of the Allies? By 1943, the strategic situation had changed dramatically. Germany's early victories had disappeared beneath the weight of a global conflict. The invasion of the Soviet Union had failed to achieve its decisive victory. American industry had entered the war with extraordinary strength. Allied bombers were striking German factories with increasing frequency. The German military needed something that could restore the balance. Conventional weapons were no longer enough. The leadership in Berlin increasingly turned towards what became known as the Wunderwaffen, the wonder weapons. These projects promised revolutionary solutions to impossible problems. A single weapon, German officials hoped, could break enemy morale, destroy critical infrastructure, or reverse a war that was slipping away. The reality was far more complicated. Some of these weapons represented genuine scientific breakthroughs. German engineers pushed the boundaries of aviation, propulsion, and missile technology. Their research would later influence the space programs of both the United States and the Soviet Union. But these achievements existed within a brutal system driven by Nazi ideology, military exploitation, and the use of forced labor. The development of these weapons came at a terrible human cost. The rocket program, for example, relied heavily on laborers imprisoned at the Mittelbau-Dora concentration camp, where thousands died under horrific conditions while manufacturing V-2 rockets inside underground tunnels. The technical achievements of the program cannot be separated from the suffering involved in creating them. The origins of Hitler's secret weapons program reached back years before the war had begun. During the 1920s and 1930s, German scientists explored rocket technology partly because restrictions placed on Germany after the First World War limited certain forms of military development. Rocket research offered a way to investigate new possibilities beyond the control of traditional weapons agreements. One of the most important figures to emerge from this environment was Wernher von Braun, a young engineer fascinated by the possibility of space travel. Initially interested in reaching beyond Earth, von Braun and his colleagues became increasingly connected with Germany's military objectives. The Army recognized that their experiments could lead to powerful new weapons. In 1937, the German Army established the Peenemünde Army Research Center on the Baltic island of Usedom. It became one of the most advanced military research facilities in the world. Scientists, engineers, and military officers worked there with resources rarely available elsewhere. Their goal was extraordinary: to build a guided missile capable of traveling hundreds of kilometers and delivering an explosive warhead with unprecedented speed and accuracy. At the time, many experts believed such a weapon was beyond practical engineering. Rockets required enormous amounts of energy. Their engines had to operate under extreme temperatures and pressures. Navigation systems had to function without the pilot or crew that conventional aircraft relied upon. The challenge was comparable to building a machine that could launch itself into the upper atmosphere, survive violent forces, and return with enough precision to strike a chosen area. The engineers at Peenemünde began solving these problems one by one. They experimented with liquid fuel rocket engines, aerodynamic designs, control systems, and guidance technology. The result was the Aggregate 4, later renamed the V2. The rocket stood approximately 14 meters tall and weighed around 12.5 tons when fully fueled. Its engine generated enormous thrust by burning liquid oxygen and alcohol. It could reach speeds of more than 5,000 kilometers per hour during flight, traveling beyond the atmosphere before descending towards its target at supersonic speed. To those who witnessed early tests, it seemed almost unreal. A machine built by human hands could rise vertically from the ground, disappear into the sky, and return as a weapon from the edge of space. Yet behind this technological achievement was a desperate race against time. Germany was not developing these weapons from a position of strength. It was developing them because traditional methods of warfare were failing. The question was no longer whether these weapons were possible. The question was whether they could arrive before Germany's enemies destroyed the regime that created them. The answer to that question depended on whether Germany could transform experimental designs into weapons of war. Creating a prototype was one challenge. Producing thousands of reliable weapons under the pressure of Allied bombing was something entirely different. By 1943, the German leadership had become increasingly convinced that advanced technology could compensate for growing military weakness. Adolf Hitler himself had developed a strong interest in revolutionary weapons, particularly those that appeared capable of striking enemies beyond the reach of conventional forces. He saw these projects not merely as military tools, but as potential instruments of political survival. However, the path from laboratory experiment to battlefield weapon was filled with obstacles. The V2 program demanded a level of engineering precision that Germany had never attempted before. Every rocket required thousands of individual components, many of them manufactured to extremely exact standards. The guidance system needed gyroscopes capable of maintaining stability during a violent ascent. The propulsion system had to control an explosion powerful enough to lift more than 12 tons into the sky while remaining stable throughout the flight. Even minor errors could cause catastrophic failure. Early test launches at Peenemünde frequently ended in disaster. Some rockets exploded shortly after launch. Others lost control and crashed far from the intended area. Engineers had to analyze each failure, redesign components, and improve manufacturing methods. The process was slow, expensive, and uncertain, but Germany's military situation encouraged urgency rather than patience. After the Allied landings in North Africa, the defeat at Stalingrad in early 1943, and the growing bombing campaign against German industry, officials demanded faster results. The rocket program received increasing support because it offered something conventional weapons could not. the ability to strike enemy territory without risking pilots or aircraft. Unlike bombers, a ballistic missile could not be intercepted by the fighter aircraft of the time. Once launched, the V-2 followed a high-speed trajectory that left defenders almost no opportunity to respond. The psychological effect was one of its greatest intended advantages. A city, under conventional bombing, could hear aircraft approaching. Warning sirens could sound. People could seek shelter. The V-2 was different. There was no approaching formation in the sky, no engine noise announcing danger. The first indication of an attack was often the explosion itself. For civilians in cities such as London and Antwerp, the weapon created a new form of fear. The sky appeared silent, but destruction arrived without warning. Yet the weapon's development came with immense human suffering. After the Allied bombing raid on Peenemünde in August 1943, German authorities decided to move production away from vulnerable coastal facilities. The chosen location was an underground complex known as Mittelwerk, constructed inside the Konstein Mountain near Nordhausen in central Germany. The tunnels had originally been created for military storage, but they were transformed into one of the largest underground weapons factories in Europe. Production lines stretched through kilometers of underground passages where workers assembled V-2 rockets under harsh conditions. The workforce consisted largely of prisoners from the Mittelbau-Dora concentration camp. Thousands of forced laborers were transported there, many from occupied countries across Europe. They worked in dangerous conditions with little food, inadequate shelter, and extreme punishment. Historians estimate that more prisoners died producing V-2 rockets than the number of people killed by the weapon itself. Exact numbers vary, but researchers generally agree that the death toll among forced laborers at Mittelbau-Dora was tens of thousands. The achievement of the rocket program was therefore inseparable from a system of exploitation and mass suffering. The production challenges remained enormous. Although engineers had created an advanced weapon, manufacturing it at scale proved difficult. The V-2 required skilled labor, specialized materials, and constant maintenance. Allied bombing disrupted transportation networks and damaged factories. Germany increasingly struggled to obtain the resources needed for large-scale production. Despite these difficulties, the program continued. The first successful long-range V-2 attacks took place in September 1944. On September 8th, a rocket struck Paris, and later that same day, another hit London. The attacks marked the beginning of a new era in warfare. For the first time in history, a nation was using operational ballistic missiles against enemy cities. More than 3,000 V-2 rockets were eventually launched against targets primarily in Britain and Belgium. London suffered repeated attacks, while Antwerp became one of the most heavily targeted locations because of its importance as an Allied supply port after the Normandy landings. The weapon was devastating, but it did not achieve the strategic transformation German leaders had hoped for. A single V-2 carried a warhead of roughly 1 ton of explosives. It could destroy buildings, kill civilians, and create terror, but it lacked the destructive power required to alter the outcome of the war. Germany had created a technological breakthrough, but not a decisive weapon. This contradiction defined the entire German wonder weapons program. The engineers achieved remarkable advances in science and engineering, but military success required more than innovation. It required production capacity, reliable supply chains, trained personnel, and strategic timing. Germany had developed weapons of the future while fighting a war it was already losing. The V-2 was not the only project consuming German resources. Across the Reich, scientists and engineers were working on aircraft that could fly faster than anything before them, missiles designed to attack from greater distances, and weapons intended to challenge Allied air superiority. One of the most ambitious examples was the development of jet aircraft. The Messerschmitt Me-262 became the world's first operational jet fighter, powered by revolutionary turbojet engines. Its design promised speeds far beyond conventional piston aircraft. Capable of reaching around 870 kilometers per hour, it was faster than almost every Allied fighter in service at the time. In testing, it demonstrated a level of performance that shocked Allied pilots. However, technological superiority did not automatically translate into victory. Production delays, engine reliability problems, shortages of strategic materials, and Hitler's own interference prevented the aircraft from appearing in sufficient numbers at the critical moment. The same pattern appeared repeatedly throughout Germany's secret weapons program. Brilliant ideas collided with practical reality. A weapon could be advanced, but factories had to build it. Engineers could solve technical problems, but armies needed thousands of machines. A prototype could impress officials, but a war was decided by logistics, manpower, and industrial strength. By late 1944, Germany possessed some of the most advanced weapons ever created, but it also faced overwhelming pressure from Allied armies advancing from both east and west. The wonder weapons had become symbols of a regime searching for salvation through technology. And as the war entered its final months, the world was about to discover that these secret projects would leave a legacy far beyond the battlefield. By the final months of the Second World War, Hitler's secret weapons program had reached its most intense and desperate phase. Across Germany, scientists and engineers continued working on aircraft, missiles, and experimental systems that promised to change warfare. But the reality on the ground was becoming impossible to ignore. Allied armies were advancing from the west after the Normandy landings, Soviet forces were pushing relentlessly from the east, and Germany's industrial base was being destroyed by constant bombing. The weapons being created in hidden laboratories and underground factories were among the most advanced of their time, but they were arriving too late to influence the outcome of the war. One of the most important comparisons between Germany's wonder weapons and Allied developments can be seen in the field of aviation. The Messerschmitt Me-262 represented a genuine revolution in aircraft design. Powered by two Junkers Jumo 004 turbojet engines, it could reach speeds approaching 870 kilometers per hour, making it around 160 kilometers per hour faster than many Allied piston engine fighters. In combat, the Me-262 was capable of attacking Allied bomber formations before escort fighters could effectively respond. Its 430mm Mk-108 cannons provided devastating firepower against large aircraft. Some German pilots achieved significant successes while flying the aircraft, and Allied commanders recognized that it represented a serious technological challenge. However, the Me-262's advantages were limited by circumstances. Only around 1,400 aircraft were produced, and far fewer were operational at any one time because of engine problems, shortages of spare parts, and fuel limitations. By comparison, American aircraft, such as the North American P-51 Mustang, were produced in enormous numbers, with more than 15,000 built during the war. The Mustang was slower, but it was reliable, easier to maintain, and supported by the vast industrial capacity of the United States. This difference reflected a wider reality of the conflict. Germany often focused on creating technically sophisticated weapons, while the Allies concentrated on producing large numbers of effective and dependable systems. The same contrast appeared in missile technology. The V-2 was the world's first operational ballistic missile and represented a remarkable achievement in engineering. No Allied nation possessed a weapon with comparable capability during the war. It could travel approximately 320 kilometers, climb into the upper atmosphere, and strike at supersonic speed. However, the weapon's impact was limited by its cost and complexity. Each V-2 required enormous resources to build, while Allied strategic bombing campaigns could deliver thousands of tons of explosives in a single operation using conventional aircraft. The United States, Britain, and the Soviet Union increasingly demonstrated that industrial scale could outweigh individual technological breakthroughs. The Soviet Union followed a different approach. Rather than investing heavily in experimental weapons during the war, Soviet planners prioritized mass production of proven designs such as the T-34 tank, which became one of the most influential armored vehicles of the conflict. The T-34 was not the heaviest or most technologically advanced tank, but its combination of armor protection, mobility, reliability, and production efficiency made it highly effective. Germany responded with increasingly complex tanks such as the Panther and Tiger. These vehicles possessed powerful guns and heavy armor, but they were expensive and mechanically demanding. The Tiger I, weighing approximately 57 tons, was feared by Allied troops because of its 88mm gun and thick frontal armor. Yet only around 1,350 Tiger I tanks were produced, compared with more than 50,000 T-34 tanks built by the Soviet Union. The evidence shows a consistent pattern. German engineers frequently created exceptional machines, but warfare depended on more than engineering excellence. It depended on production, maintenance, fuel, training, and the ability to replace losses. The Wonder Weapons program also included projects that remained unfinished or existed only as prototypes. Aircraft, such as the Horten H-0229 flying wing, demonstrated ideas that would later influence modern stealth aircraft design. The Heinkel HE-162 Volksjäger was developed as a lightweight emergency fighter intended for rapid production. Other concepts included long-range bombers, advanced submarines, and guided weapons. Some of these projects contained ideas decades ahead of their time. Others consumed resources that might have been used more effectively elsewhere. Historians continue to debate the overall value of these programs. Some argue that German research accelerated important technological developments that shaped the post-war world. Others emphasize that many projects represented a strategic mistake, diverting manpower and materials away from weapons that could have had a more immediate impact. What is certain is that the collapse of Nazi Germany did not end the story of these technologies. When Allied forces captured German research facilities in 1945, they discovered an extraordinary collection of scientific knowledge, technical documents, and experimental designs. Both the United States and the Soviet Union competed to obtain German expertise. Operation Paperclip, conducted by the United States, brought numerous German scientists to America, including Wernher von Braun and many members of the rocket team. Their knowledge became part of the foundation for the American ballistic missile program and later the space program. In 1969, von Braun's work contributed to the development of the Saturn V rocket that carried astronauts to the Moon. The Soviet Union also acquired German rocket specialists and technology. Captured research influenced Soviet missile development and contributed to the early space race. The legacy of Hitler's secret weapons program was therefore deeply complicated. The technology helped shape humanity's exploration of space and the development of modern aerospace engineering. Yet its origins were connected to a dictatorship that used forced labor, pursued aggressive warfare, and caused immense suffering. The weapons themselves became historical contradictions. They represented human creativity and scientific achievement, but also the destructive purposes to which that creativity was directed. The immediate battlefield impact of these weapons remained limited. They did not stop the Allied advance. They did not save Germany from defeat. They did not fulfill the promises made by Nazi officials who claimed that revolutionary technology would deliver victory. But their influence after the war was profound. The development of guided missiles changed military planning forever. Nations began investing in long-range rocket systems, eventually creating intercontinental ballistic missiles capable of carrying nuclear weapons across continents. Jet technology transformed aviation, leading to the modern age of high-speed aircraft. Research into aerodynamics, propulsion, and materials continued to influence engineers around the world. The hidden laboratories of wartime Germany had created more than weapons. They had created ideas that would define the decades that followed. If you're enjoying this journey through history, subscribing genuinely helps us continue bringing remarkable true stories like this to the channel. The story of these secret weapons was not only about machines. It was about the people who designed them, the workers forced to build them, the soldiers who faced them, and the scientists who carried their knowledge into a new era. And as the war ended, the world was left with a difficult question. How should humanity remember discoveries created in the service of destruction? In the years after the Second World War, the abandoned laboratories, underground factories, and scattered research facilities of Nazi Germany became places where the future was quietly being assembled from the remains of a defeated regime. The war had ended, but the ideas developed inside those secret programs continued moving forward. The rockets that once carried explosives towards European cities would eventually become instruments of scientific exploration. The aircraft designed for desperate defense would influence the next generation of aviation. The research created under the pressure of war would help shape the technological competition that defined the second half of the 20th century. But behind every technical achievement stood the reality of the circumstances in which it was created. The story of Hitler's secret weapons program cannot be understood simply as a tale of innovation. It was also a story of ambition, desperation, exploitation, and the dangerous relationship between science and power. The same engineering skill that produced remarkable advances was controlled by a regime that used those advances for destruction. Among the most enduring reminders of this history are the surviving examples preserved in museums and archives around the world. V-2 rockets remain on display at institutions including the National Air and Space Museum and the Deutsches Museum, allowing visitors to see the enormous scale of the weapon. These preserved machines reveal both the complexity of the technology and the historical circumstances surrounding its creation. The remains of Peenemünde also survive as a historical site. What was once a highly secret military research center is now a place of education and remembrance. The empty launch areas, ruined buildings, and surviving structures tell a story that extends far beyond engineering. They represent a moment when scientific progress was placed at the service of a destructive ideology. The Mittelbau Dora Memorial in Germany preserves the memory of the prisoners who suffered and died while producing V-2 rockets. Their experiences remain central to understanding the true cost of the program. Without acknowledging their suffering, any discussion of the rocket's technical achievements would present only part of the historical picture. The Wonder Weapons program ultimately revealed a fundamental lesson about warfare. Technology can provide extraordinary advantages, but it cannot overcome strategic reality. Germany possessed engineers capable of designing advanced machines. It possessed scientists who pushed beyond the limits of existing knowledge. It created weapons that seemed to belong to a future age. But wars are not won by technology alone. They are won through resources, organization, logistics, industrial strength, and strategic decision-making. By 1945, Germany's enemies possessed overwhelming advantages in each of these areas. The United States could produce aircraft, tanks, ships, and ammunition on a scale unmatched by any nation in history. The Soviet Union could replace enormous battlefield losses while continuing major offensives. Britain maintained its industrial base and global supply networks despite years of conflict. Against this reality, even the most advanced German weapons could achieve only limited results. The V-2 was faster than any previous weapon of its kind. The Me-262 was the first operational jet fighter. The Tiger tank possessed extraordinary firepower. Experimental aircraft designs demonstrated concepts that would influence aviation decades later. Yet none of them could reverse Germany's defeat. Their greatest impact came not during the war, but after it. The beginning of the Cold War transformed German technological knowledge into a strategic resource. Both the United States and the Soviet Union recognized that rocket technology would become central to future military power. The race to develop longer-range missiles eventually expanded beyond Earth itself. The engineers who once worked on weapons for Nazi Germany became involved in programs that helped launch satellites, explore space, and place humans on the moon. The transformation was one of the most remarkable technological transitions in modern history. A rocket designed during the darkest years of the 20th century eventually contributed to one of humanity's most inspiring achievements. But history does not erase the circumstances of its creation. The same tunnels where rockets were assembled were places where prisoners endured starvation, exhaustion, and death. The same laboratories that produced advanced research existed within a system built upon dictatorship and war. The achievements and the crimes existed together, inseparably connected. That is why the story of Hitler's secret weapons program remains so important. It is not merely the story of missiles, aircraft, and machines. It is the story of what happens when human intelligence is combined with unlimited political ambition. It is the story of how innovation can be directed towards destruction, and how the consequences of those decisions can continue long after the battlefield has fallen silent. Return now to the darkness above Peenemünde in August 1943. The Allied bombers are approaching through the night sky. Below them, hidden among forests and coastal sands, scientists are working on a weapon unlike anything the world has ever seen. The buildings are illuminated by artificial light. Engineers move between laboratories and workshops. Test equipment fills the rooms. Outside, the sound of approaching aircraft grows louder. At that moment, nobody knows exactly what the future will bring. The men inside the facility believe they are creating a weapon that could transform warfare. Allied intelligence officers fear they may be witnessing the beginning of a new age of conflict. The prisoners forced to support the program know only the suffering of the system surrounding them. All of them are part of the same historical moment, a moment when humanity reached higher than ever before in the pursuit of technology, while also revealing how dangerous that pursuit could become. The rockets developed in those secret facilities did not save Nazi Germany. The wonder weapons did not deliver victory. They could not overcome the industrial power of the Allies or change the final outcome of the war, but they changed the world. They changed how nations thought about distance, speed, and warfare. They changed the future of aviation. They helped create the foundations of modern rocketry and space exploration. They showed that the boundaries of engineering could be pushed further than many had imagined. And they left behind a warning. The greatest inventions in human history are not defined only by what they can achieve, but by the choices made about how they are used. Inside Hitler's most secret weapons program was a vision of the future. It was a vision built from genius and tragedy, discovery and destruction, ambition and suffering. And the final legacy of those weapons is not simply that humans learned how to reach the sky. It is that history reminds us to question where we are going and what kind of world we intend to build when we finally get there.